Okay, let's do another example of looking at the relative motion. So let's consider a boat crossing a river. So we have a river, and the water is running this way to the right. And we have a boat right here. And the boat is going to point straight across the river. And so let's say the river is a width of 17.5 meters. Let's say the water is moving at some velocity v sub w, velocity of the water, and that's equal to 1.65 meters per second. The boat is moving at a velocity relative to the water. So what's happening is the water is moving, the boat's moving across the river, but the water the boat is going on is going down the river. And so that means that it's moving relative. So the relative velocity, the velocity of the boat is going to be 1.85 meters per second. And so what I want to know is, where does the boat end up over here? Okay, and obviously it's not going to end up directly across the river because as it's crossing the river, the river's pushing it this way. And so I want to know, where does the boat end up? Well, the total velocity of the boat, the relative velocity of the boat here, is equal to 1.85 meters per second J. The velocity of the water, vector form, is 1.65 meters per second I. Velocity of the boat relative to the shore is going to be equal to the sum of the velocity of the boat relative to the water plus the velocity of the water relative to the shore. So that's going to be 1.65 meters per second I plus 1.85 meters per second J. Okay, so this is the y part of the velocity. This is the x part of the velocity. So the y part of the velocity, it goes that distance, 117.5 meters. So the time that it takes to cross the river is going to be 17.5 meters divided by the 1.85 meters per second. And so that comes out to be 9.46 seconds. Okay, during that time, it's going down the river. So we know that, the y distance equals v y naught t, and the x distance can be v x naught t. So the distance down the river is going to be 1.65 meters per second times 9.46 seconds. So this comes out to be 15.6 meters downstream. Okay. So water was going this way. The boat was pointed this way, but ended up here. Now, suppose that the operator of the boat doesn't want to end up that far downstream. So the operator of the boat thinks, well, what I'm going to do is I'm going to point my boat 45 degrees upstream. So now I want to know, where does the boat end up? Okay, and so now the velocity of the boat relative to the water is going to be, we're assuming that the water is still going the same speed, and then the boat velocity is still 1.85 meters per second, and the water velocity is still 1.65 meters per second. Okay, so the velocity of the water vector is going to be 1.65 meters per second I. The boat velocity is going to be 1.85 meters per second sine 45 degrees negative I, and 1.85 meters per second cosine 45 degrees J. Okay, so the relative velocity of the boat is going to be minus 1.31 meters per second I plus 1.31 meters per second J. Total velocity here of the boat is going to be the velocity of the boat relative to the water plus the velocity of the water, just like before. So this is the velocity of the water, 1.65 meters per second I, and we add that to this I component, and so the velocity of the boat is now going to be 0.34 meters per second I plus 1.31 meters per second J. So this is going to be the X component. This is the Y component of the velocity. Well, we got the same. We know that the time is going to be the Y distance divided by the Y component of the velocity. So that's going to be 17.5 meters divided by 1.31 meters per second. So that's going to be 13.4 seconds. The X distance is going to be the Vx times time. So that's going to now be 0.34 meters per second times 13.4 seconds. So now the X distance is 4.54 meters. Okay, so water's going this way, the boat here, the boat points 45 degrees up, but still ends up downstream, just not as far downstream. And so the next question is, well, what angle would the boat operator have to point the boat so that you end up going straight across the river? So now we have the river still 17.5 meters. The water velocity is still 1.65 meters per second. And now the operator wants to go straight across and point the boat upstream some angle theta. So how far upstream do you point in order to go straight across, and how long is it going to take? Obviously, it takes the least amount of time if you just point the boat straight across, but if you point at an angle like this, it's going to take longer. So what do? Well, we think about it, and we say, well, in order to go straight across, the velocity here, the velocity is always going to be the relative velocity here of the boat is always going to be equal to, VB, in this case, minus VB sine theta I plus VB cosine theta J. Now, remember, why sine, cosine? Opposite side of the angle is sine. Okay, it's going to the left, so that's going to be the negative. Okay, remember, X is not always cosine, Y is not always sine. It depends on how you measure the angle. So, the total velocity here of the boat is going to be minus VB sine theta plus the velocity of the water, I, plus VB cosine theta J. Okay, so in order for it to go straight across, this velocity has to be equal to 0. So we could therefore say that minus VB sine theta plus VW equals 0. Sine theta equals VW over VB. So theta equals the inverse sine of VW over VB. So that's going to be equal to the inverse sine of velocity of the water, 1.65 meters per second, divided by 1.85 meters per second, velocity of the boat. So that turns out to be 63.1 degrees. So that means that the boat operator has to point the boat here an angle of 63.1 degrees upstream in order to end up going directly across the river. Okay, so it's very, very much upstream. Now the question, how long does it take now to do this? because now you're going against the water most of the time. So to figure out how long it takes, then we go back and we say, well, the time is going to be equal to the y divided by vy. Well, what is vy? Vy was the velocity of the boat cosine theta. So vy is going to be 1.85 meters per second times the cosine of 63.1 degrees. So Vy is going to be 0.837 meters per second. So the time is going to be 17.5 meters divided by 0.837 meters per second. So the time is now going to be 20.9 seconds to cross the river. And so this is an example of relative motion. Once again, another example of relative motion.